Welcome to Syntax Grid. Today we're comparing two powerful regression techniques, Decision Tree Regression DTR, which predicts by branching data into paths, and Support Vector Regression SVR, fitting data within smooth margins.
Introduction. Today, we're exploring Decision Tree Regression, a straightforward yet powerful tool for continuous value prediction. Simple and interpretable, DTR models are easy to understand and visualize. Nonlinear relationships, DTR can capture complex nonlinear relationships between variables. Feature importance. The model can highlight the most important features influencing the target variable. How DTR works. At each node, the algorithm chooses splits that minimize prediction errors, often using metrics like mean squared error. Data preparation. Collect historical data. Gather historical data with a 5-minute time interval for the variable you want to predict. Feature engineering. Create relevant features like lagged values, moving averages, and external factors. Model training. Split data. Divide the data into training and testing sets. Train the model. Use a DTR algorithm. From scikit-learn to train the model on the training data. Hyperparameter tuning. Optimize hyperparameters like maximum depth, minimum sample split, and minimum samples leaf to improve performance. Model evaluation. Evaluate performance. Use metrics like mean squared error, MSE mean absolute error, MAE, and R squared to assess the model's accuracy. Cross-validation. Employ cross-validation to get a more reliable estimate of the model's performance. Model deployment. Integrate the model. Deploy the trained DTR model into a real-time system. Make predictions. Use the model to predict the value of the target variable for the next 5 minutes based on the current input features. Pros and cons. Pros, easy to interpret, handles both numerical and categorical data, robust to outliers. Cons, prone to overfitting without pruning, less effective for smooth, continuous data trends. Uses and real-life applications. Examples, customer segmentation, predicting simple, continuous trends. Quick wrap-up, use DTR when interpretability and handling diverse data structures matter most. Introduction. We're breaking down Support Vector Regression, or SVR, technique used for predicting continuous values. Effective for nonlinear relationships, SVR can handle complex patterns in the data. Robust to outliers, it is less sensitive to outliers compared to linear regression. Kernel trick, SVR can map data into higher dimensional spaces to find nonlinear patterns. How SVR works. SVR aims to minimize errors, placing emphasis on data points closest to the boundary, support vectors. The goal is to keep predictions as accurate as possible while staying within this margin. Data preparation. Collect historical data. Gather historical data with a 5-minute time interval. Feature engineering. Create relevant features as mentioned earlier. Model training. Split data. Divide the data into training and testing sets. Train the model. Use an SVR algorithm, Chi, from scikit-learn to train the model. Hyperparameter tuning. Optimize hyperparameters like the kernel function, linear, polynomial, radial basis function, regularization parameter, C and epsilon. Model evaluation. Evaluate performance. Use the same metrics as for DTR to assess accuracy. Cross-validation. Employ cross-validation to get a reliable estimate. Model deployment. Integrate the model. Deploy the trained SVR model into a real-time system. Make predictions. Use the model to predict the value of the target variable for the next 5 minutes. Pros and cons. Pros handles high-dimensional data, suitable for complex relationships. Cons, computationally intensive, sensitive to parameter tuning. Uses and real-life applications. Examples: predicting stock prices, weather forecasting, etc. Use SVR when your data has complex, nonlinear relationships and you need smooth predictions.
Thanks for joining us at Syntax Grid. Today we covered Decision Tree Regression, DTR, which splits data into predictive branches, and Support Vector Regression, SVR, known for fitting data within smooth margins for accurate predictions. We hope this helped clarify their strengths and uses. Be sure to explore our other videos for more on data science and machine learning. Until next time.